Hello, focused learners. Welcome back to The Explainer. I'm going to be your mathematics teacher for today's session. Look, if you've been staring at past exam papers and feeling, just completely overwhelmed by algebra and those tiny little subscripts, well, you're in exactly the right place. Today, we're tackling a totally classic exam hurdle, number bases. Okay, let's dive into this. We are going to completely deconstruct a very specific, kind of tricky problem from the WAEC Mathematics 2025 question pool, so you can truly master the mechanics behind the math.
Here's our game plan for today. We'll start off with the WAEC 2025 challenge, then make sure we're really understanding number bases. After that, we'll do a step-by-step conversion, actually solving the equation, go over verification and some common mistakes, and finally, we'll wrap up with a rapid-fire quiz checklist.
Section 1, the WAEC 2025 challenge.
All right, here is the exact question straight from the exam. WAEC Mathematics 2025 question 2. Given that 21 base 5 is equal to 14 base x, find the value of x. And you've got your multiple choice options. A is 4, B is 5, C is 6, and D is 7. Now, I know at first glance, seeing an x as a subscript base, it can honestly cause a bit of panic, right? Like, how on earth do you solve for a base? Well, take a deep breath. By the end of this explainer, you're going to confidently know the answer and, more importantly, the exact repeatable methodology to get there every single time.
Section 2, understanding number bases.
To make this whole abstract concept feel incredibly intuitive, I want you to think about what I call place value houses. So imagine every number base is a totally distinct house, and this house has a very, very strict bouncer at the front door. Now, this bouncer has one absolute rule. Absolutely no digit is allowed inside if it is equal to or larger than the base of the house itself. So in a base 5 house, the only digits allowed to live inside are 0, 1, 2, 3, and 4. The digit 5? Strictly forbidden. If you try to bring a 5 into a base 5 house, nope, it bundles up and gets pushed right into the next room over. It's just a beautifully simple analogy, but it perfectly visualizes a really core mathematical constraint. And honestly, that analogy leads us straight into how we decode these WAEC questions. First up, look for your keywords. Phrases like given that, base, find x, equal to. These basically scream at us that we're balancing an equation. But here is the absolute most powerful tool in your entire arsenal, the golden rule. A base must be greater than any digit contained within the number. Let's run a really quick logic check on our specific problem. We have the number 14 base x. The digits there are 1 and 4, right? Well, according to our golden rule, the bouncer at the base x house says the base has to be strictly greater than the highest digit inside. The highest digit is 4. Therefore, logically, x must be greater than 4. Now look back at your multiple choice options for a second. Option A was 4. You can instantly cross option A off your list before you even do a single drop of actual math. Literally, that is the power of just understanding the concepts.
Okay, so to actually solve equations with different bases, we need a universal translator. And for us, that's base 10, our standard everyday counting system. Looking at our conversion framework, we always use powers starting from 0 on the far right and increasing as we move to the left. In that ones column, the power is 0. In base 5, 5 to the power of 0 equals 1. And in base x, x to the power of 0, well, it also equals 1. Remember, anything to the power of 0 is 1, always. Then, moving left to the base value column, the power becomes 1. 5 to the power of 1 is just 5, and x to the power of 1 is simply x. This specific structure? It's the absolute key to expanding both sides of our equation.
Section 3, step-by-step conversion.
So we have two distinct parts to deal with here. The left side is 21 base 5, and the right side is 14 base x. Notice how we treat the known base, which is 5, versus the unknown base, x. And actually, here's the amazing secret to algebra. You don't treat the unknown x any differently than the known 5. You literally just apply the exact same mathematical process to both sides. No special treatment whatsoever.
Section 4, solving the equation. All right, let's roll up our sleeves. Step 1, let's convert 21 base 5 into base 10. We take the first digit, which is 2, and multiply it by the base, 5, to the power of 1. That's 10. Then we take the second digit, 1, and multiply it by the base, 5, to the power of 0, which, remember, is just 1. So 10 plus 1 equals 11. Simple, right? Now step 2. Let's convert 14 base x to base 10 using that exact same logic. We take the digit 1 and multiply it by x to the power of 1. That just gives us x. Then we take the digit 4 and multiply it by x to the power of 0, which again is 1. 4 times 1 is 4, so we get x plus 4. Moving to step 3, let's set up our brand new base 10 equation. We just replace the original pieces with our new base 10 values. This leaves us with a really beautiful, simple equation, x plus 4 equals 11. Finally, step 4, solve it clearly. To isolate x, we just subtract 4 from 11.
And boom, we arrive at our answer, 7. By just methodically breaking down that conversion process, we've completely stripped away all the complexity of the bases and found that x is equal to 7. Which means if we look back at our WAEC options, the correct answer is undeniably option D.
Section 5, verification and mistakes. Now an amateur student finds the answer and just moves on to the next question, right? But master mathematicians, we always verify our work. So let's substitute 7 right back into 14 base 7. Does 14 base 7 actually equal 11 in base 10? Let's see. 1 times 7 is 7, plus 4 times 1 is 4. 7 plus 4 is, indeed, 11. Flawless. Now to protect those precious exam marks, you really need to beware of a few common traps. So the crucial point is knowing where others go wrong. Mistake number 1 is an absolute classic, forgetting that any number or variable to the power of 0 equals 1. If you accidentally write x to the power of 0 as 0, the whole problem completely collapses. Mistake 2 is mixing up the base with the powers, like multiplying by the power instead of using it as an exponent. Don't do that. And mistake 3 is ignoring our golden rule. Remember the place value house rule? A base must be strictly greater than its digits. Keep these specific pitfalls in mind, and you will absolutely protect your hard-earned exam marks.
Section 6, rapid-fire quiz checklist.
Okay, time to lock this in. Here is a rapid-fire challenge for you, pulled directly from WAEC 2019, question 8. If 23 base y is equal to 1111 base 2, find the value of y. Now, we know the highest digit in 23 is 3, right? So y absolutely must be greater than 3. But look at the options. Both options A and B are greater than 3, so our quick logic check doesn't magically eliminate either one this time. You're actually going to need to do the math. I challenge you to apply the exact same conversion steps we just learned today. Convert the right side from base 2 to base 10. Then, set it equal to the left side expanded in terms of y. I guarantee you have all the tools you need to solve this right now.
So whenever you face a number-based problem on the exam, just follow this revision blueprint. First, identify your key words, like find x or equal to. Second, apply the golden rule logically right off the bat to eliminate impossible multiple-choice answers immediately. Third, convert everything to base 10, that's your universal translator. Fourth, balance the resulting algebraic equation cleanly. And finally, be a master mathematician and substitute your answer back in to verify it's correct. We've totally demystified number bases today, right? We've transformed them from these intimidating subscripts into just straightforward, easy algebra. So I'm going to leave you with this final provocative question. Now that you hold the exact blueprint, are you going to let a simple subscript letter dictate your exam confidence, or are you ready to confidently break down every single number-based problem WAEC throws your way? Thank you so much for joining me on The Explainer today. Keep learning, keep verifying, and I will see you in our next masterclass.